Hi, this is Yuri. In this video, I'm going to give you a simple example which demonstrates how to use NCurses with Haskell. The NCurses library helps us to build simple text-based user interfaces. With the help of it, you could interact with your Haskell program, and you will be able to create useful tools and games as well. So, let's get started. This example program that I will show is really simple and could serve as a skeleton for further development. To compile and link the program, you can use the makefile or the ghc command. When we run it, in the top left corner we can see the position of the cursor, what we can change by pressing the WASD keys. We can toggle a more verbose output with the V key. When we turn on the verbose mode, a timeout counter will be visible. With the help of it, I can demonstrate several important concepts, but worth to understand. To quit, we use the Q or escape. The environment that I will use for this demo is a Docker machine, created by this Dockerfile. Of course, you will find a link in the description. The Haskell specific packages section describes the minimal dependencies that you can install manually. Of course, it is not necessary to use this context. However, I recommend this if you would like to feel a sense of achievement during your first steps. The harder way is when we are using Cabal or stack tools, which are extended package managers. If a language that you have to use requires a package manager, well, you decide. Okay, let's see the Haskell program. To use NCurses, it is necessary to import the UI NCurses module, and in this example, it is totally enough for us. We will use a record with X and Y fields called selector functions to represent the position of the cursor. And to make it easily printable, we're deriving show. Without this, we will get an error if we want to use the show function in the argument of drawString. I will show it. I like to create named default values. In some cases, it helps the reading of the source. The showDebug type has two data constructors, showDebug and noDebug. Of course, it could be a boolean, however, usually we could express more information in this way. If we only want to use expressing names inside our source files, we could say that it is almost always a good approach. However, if we want to place our functions into modules, sometimes we want less style dependencies. This makes possible to use functions in a more general context. If this is our goal, bool could be a good choice also. So, we have to find a balance here. In this example, I do not want to reveal too much about a good design to keep everything simple. I just would like to mention that usually it's a good idea to decompose our program into modules. However, it could have an effect to its internal structure also. A good example when we are separating the GUI, graphical user interface related parts, from the logic of the program. Here, right now, we are not focusing on these design principles, but we are definitely going to speak about this separation later. Here, we are at the most important place. In Haskell, there are no infinite while loops, but we are usually using in imperative languages to write a scheduler or an event handler. Instead of loops, here we have recursion, hopefully tail recursion, but it is another story. Because we try to see everything as a function, and the function must depend on only from its parameter, we have to define a context in which our program will run. By transforming this context, we are able to create a whole new modified word for the next recursive call. Regarding to the parameters, I would like to encourage you to familiarize yourself with the concept of querying. I will speak about this topic in my next videos. When we are incrementing a value in our word, we could think of this manipulation as an assignment. It is usual, but here we have to extend our mind and we have to assign a new value to the whole word for the whole context. And this new word will include the effect of the assignment that we would have made. This is what you can see here in the inc timeout counter function. It takes a loop parameter type value and returns a modified one. In this case, the difference between the parameter and the calculated return value will be the value of the timeout counter. If we are using this syntax, we could express that its new value somehow depends on its previous value, which was C. It is an example of the pattern matching. Okay, let's see how the main function works. It runs curses, it gets the default window, and then it's passing it to our infinite loop. To get more info about the parameters, look at the where clause and read the name of the parameters. It is not an easy task at all to give descriptive names for the parameters at the actual level of abstraction, but we have to do our best to express the thought process. After all, the source text is a communication channel between two or more programmers. Now we know that at the first call of the loop function, we have a default window and no event had occurred before, and we are starting from the state represented by the initial loop parameters. I said that it is a recursive function, however, it is only visible if we look through its definition and find the recursive calls. Let's search for loop. Here we can see the event handler part. If we didn't get any event within the defined timeout period, E will be nothing. And we call our loop again with a slightly different parameters. We keep the window, but we are updating the event and incrementing the timeout counter value. This is what you can see here. If you would like to provide some mechanism to quit from the program, the queue and escape cases should not contain the recursive call. This is what you can see in the next cases. If we are pressing W, we move the cursor to the beginning of the second line and draw the W pressed string. Then we are creating a new modified word for the next iteration with the appropriate cursor position. Right now, I do not want to overcomplicate things. I am just using this pattern where the similarities between the cases are clearly visible. The mechanisms are similar in the case of A, S, and D keys. When the user presses the V key, we just toggle the show debug without modifying the position of the cursor. And as you can see in any other cases, we leave the loop parameters as they were. The only thing what worth to mention in the main function is the parameters of the get event, because it could cut the execution into two parts. This is what I would like to show here. So right now we pass through this line when the user pressing a key or when the timeout is over. Be careful with this and read this comment. I think this line is a really good example of how to use your existing Haskell knowledge to draw something, for example a line filled with spaces. However, to clear a line there is a built-in solution, and now I will show you how to find that in the documentation. In the NCurses documentation we can see that there is a function called clr to EOL, clear to end of line. Here you can see its original C declarations or prototypes. But how they wrapped it in Haskell? This is the question. Go to the Haskell module documentation, scroll down and click on the source to see the source code where the function had defined. Just try to search the name what we have known from C. And here we are. Check it. If you would like to learn more, By searching for the expressions of this file, you may find more resources which helps you to improve your knowledge in this topic. I am going to help you on this way with my next videos. I hope you enjoyed this demo, and I hope you can use some parts of this example in your programs. Thank you for your time. Goodbye.